Welcome back to Maths with Mrs. J. In our previous video, we learned about the product rule. And even though the rule itself looked a little bit unwieldy, actually using it is relatively easy. I don't normally set them out in full with the let u be this and let v be that. I just do, or with the product rule, I just do first thing times derivative of second thing plus second thing times derivative of first thing. Highly unmathematical terminology, but it works and it helps me remember it and it will help you remember it too, so why not? Your quotient rule unfortunately looks even worse. Let's have a look at it. Not very nice looking at all, is it? Please bear in mind that if you do have a product or a quotient, you can't just differentiate each bit and then either multiply or divide those derivatives. There is a special rule. Now, I will prove this rule to you once I've taught you one other rule. So a couple of videos time, I'll actually show you a proof of this rule. This rule says that dy dx is v du dx minus u dv dx on v squared. The way I remember this, bottom times derivative of top minus top times derivative of bottom on bottom squared. And yes, I did say that. It's not very mathematical, but it helps me remember it. Let's just set the first one out in full, just so that we can say that we've done one in full. So we will let u be our numerator expression, so 3x plus 5. So obviously du dx is just going to be 3. Let v be our denominator, so x squared plus 1, so dv dx is 2x. Now our rule says that dy dx is v times du dx minus u times dv dx all over v squared. That's our quotient rule. We're going to move up here now. So v is x squared plus 1. Du dx was just 3 minus u is 3x plus 5 and dv dx is 2x. So we're going to get all of that in our numerator over v squared, which is x squared plus 1 squared. Okay, tidying up our numerator, we get 3x squared plus 3 minus 6x squared minus 10x all over our x squared plus 1 squared. So we're going to get what? Negative 3x squared minus 10x plus 3 all over this squared. And by the way, for a rational expression to equal 0, the numerator has to be 0. Just bear that in mind for future reference. Okay, so that was a lot of rigmarole there that really wasn't entirely necessary. I normally would go straight to this line of working here. Let me show you. Let me also point out that I'm doing ones here that normally you might not necessarily have to use the quotient rule for, but just to teach you how to use the quotient rule, I'm using fairly simple examples. What I do, this is how I do it. I go dy dx is bottom times derivative of top minus top times derivative of bottom, which is just 1. Might just get a straight line happening here because otherwise I'm going to make a big mess all over our x minus 1 squared. Okay, let's expand, gather like terms, etc. So in our numerator, what have we got? We've got 2x squared plus x minus 2x and minus x minus 1, and then minus all of this. So minus x squared minus x minus negative 2, which is plus 2. Get a straight line happening again. All over our x minus 1 squared So what have we got? X squared minus 2x plus 1 on x minus 1 squared. What does that numerator look like? It's a perfect square, isn't it? It's in fact x minus 1 squared. Look what's going to happen here. We're just going to get 1. Now let me show you why. Normally what you would do before differentiating is you would simplify as much as possible. Let's just get a different colour happening. So this y here, the numerator is x plus 2, x minus 1, and your denominator is x minus 1. And we're allowed to cancel because x is not allowed to be negative 1. So really all you've got is y is x plus 2. Well, if y is x plus 2, dy dx, of course, is just 1. Okay? Now, in my next video, I'm going to teach you the chain rule, which is to do with functions of functions. Once I've taught you that, then we can put that together with our product and quotient, and then we can do a lot more interesting things.